Okay, problem session for calculus. We're up to lesson 8. Are there any questions about homework or the material on using the derivative to find the tangent to a curve? Any questions? So let's just review a little bit properties of the derivative. The way it's introduced is with the geometrical problem. You have a curve. Let's say that's the graph. And at some point on the curve, this is x equals c. So this point has coordinates c comma f of c. And the problem is to find the tangent line to the curve at the point. And you know a line is determined by a point on the line. Here's a point on the line and the slope. And the slope of the tangent line at x equals c is the derivative. Which we denote in various ways, f prime of c, for example. And this is defined to be the limit of f of c plus delta x minus f of c divided by delta x as delta x goes to 0. So this is the fundamentally important definition of the derivative of a function at a point c. And a geometrical interpretation is that this is the slope of the tangent line. And in section 3.2, we work out some properties of the derivative. So the first property is the constant rule. If you have a constant function, f of x equals c for all x, this is the graph of the function. And it's a horizontal line. The slope of a horizontal line is 0. So f prime of c is 0. Or the derivative with respect to x of the constant function c is 0. Right? If you understand the derivative as the slope of the tangent line, the horizontal line has slope 0. The most frequently used derivative rule is the rule for the derivative of a power. So let's call this the power rule. And what the power rule says is, if you have the function x to the n, the derivative of x to the n is nx to the n minus 1. For all n, doesn't matter what n you choose. This just shows an example for n equal 2. Just 1 second, excuse me.
Excuse me, Professor, I can't hear you.
Okay, sorry. So I'm going to look at the case n equal 2. Our function is f of x equal x squared. So the derivative, by definition, is the limit as delta x goes to 0 of f of x plus delta x minus f of x over delta x. So we'll do a little calculation. F of x plus delta x, that means x plus delta x squared. That's x squared plus 2x delta x plus delta x squared. And so if I look at f of x plus delta x minus f of x, this is f of x plus delta x, and f of x is x squared. And you see that the x squareds cancel. So this is just equal to 2x delta x minus delta x squared. And I can factor a delta x out of this. This is delta x times 2x, oops, it's a plus sign, 2x plus delta x. So I'm looking at f of x plus delta x minus f of x divided by delta x. This is the limit as delta x goes to 0. When I divide by delta x, I'm left with just this, 2x plus delta x. Delta x goes to 0, x is some fixed number, so this limit is just 2x. So we just proved that the derivative of x squared is 2x. And the proof for an arbitrary positive integer is in the lecture on YouTube. I don't need to go over that again, but this is just to give the right idea. Okay. Any questions about this? But this is a very useful rule. According to this rule, right, the derivative of x to the n is nx to the n minus 1. So the derivative of x cubed is 3x squared. The derivative of x to the 4th is 4x cubed. The derivative of x to the minus 1, so this is n equals minus 1, so it's minus 1x to the minus 1 minus 1, which is minus x to the minus 2. Or another way of writing that is the derivative of 1 over x is minus 1 over x squared. And this applies as well to fractional exponents. What's the derivative of the square root of x? So the square root of x means x to the power a half. So this is this rule with n equal to a half x to the 1/2 minus 1, or 1/2 x to the minus a half. Or if you like, 1 over 2 times x to the 1/2, or 1 over 2 times the square root of x. So the derivative of the square root of x is 1 over 2 times the square root of x. So these calculations you need to practice a lot, because this is something that you need to be able to just work out very, very quickly at the drop of a hat. So for example, this is just a very simple case. Find the tangent line to the curve y equals x squared at x equal minus 2. So we're looking at the function f of x equal x squared. The derivative of x squared is 2x. When x is minus 2, the derivative of minus 2 is 2 times minus 2, or minus 4. What does the graph of this parabola look like? This is the graph of the parabola. And this is the point, minus 2, 4. And the tangent line, some line over here. So for the tangent line, at x equals -2, has slope minus 4. So what is the equation of the tangent line? The line through the point minus 2, 4 with slope minus 4 is given by y equals minus 4 x minus minus 2 plus 4. That's minus 4 times x plus 2 plus 4. That's minus 4x minus a plus 4 minus 4. So we're using the point slope formula to find the equation of the tangent line. Okay. Any questions about this? There's some other basic differentiation rules. There is what is sometimes called the constant multiple rule. The derivative with respect to x of a constant times f of x is the constant times the derivative of x. So for example, the derivative of x cubed is 3x squared. The derivative of 7x cubed, you know, this says you can take the constant outside. It's 7 times the derivative of x cubed. That's 7 times 3x squared, or 21x squared. That's the constant multiple rule. There's also a sum and difference rule. If you take two functions and you add them, the derivative of the sum is the sum of the derivatives. And the derivative of the difference is the difference of the derivatives. And the constant multiple rule and the sum and difference rule now allow us to differentiate any polynomial. So suppose we have a polynomial like f of x equals x cubed minus 4x plus 5. So the derivative of x cubed minus 4x plus 5 using the sum and difference rule is going to be the derivative of x cubed minus the derivative of 4x plus the derivative of the constant function 5. This is the derivative of x cubed is 3x squared. You can take the 4 by the constant rule and take the 4 outside. This is like the derivative 4 times the derivative of x. The derivative of x is 1. And the derivative of 5, a constant, is 0. So we get 3x squared plus 4. Right? Why is the derivative of x equal to 1? Well, x, it's like x to the first power. So this is 1 times x to the 1 minus 1 by the power rule. That's 1 times x to the 0. X to the 0 is 1. This is 1. Right. The idea of these sessions isn't so much for me to review the material that's in the lecture, but to answer questions. But it's always good if you come to these sessions with some questions. What about trig functions, sines and cosines? So two very important formulas are that the derivative of the sine is the cosine, and the derivative of the cosine is minus the sine. And the proofs of these use identities that we proved early on about limits. So let's actually prove that. Recall that we proved that the limit of sine x over x as x goes to 0 is 1, and the limit of 1 minus cosine over x, 1 minus cosine over x as x goes to 0 is 0. So suppose we want to find the derivative of the sine of x. That's the limit as delta x goes to 0, sine of x plus delta x minus sine x over delta x. So in calculus, you have to know pre-calculus. And one of the addition formulas for a trig function is the addition formula for the sine. Sine of x plus delta x is sine x sine delta x minus cosine x cosine delta x. That's the addition formula. So sine of x plus delta x minus the sine of x is this. Oops, I'm sorry. I wrote this. I wrote down the addition formula for the cosine and not the sine. Let me do this correctly. Sine of x plus delta x is sine x cosine delta x plus sine of delta x cosine x. So when I subtract the sine of x from that, I get sine x cosine delta x plus sine delta x cosine x minus the sine of x. So let's see, this term is the sine of delta x cosine x. And I have a sine here and I have a sine here. Let me write this as minus the sine of x times 1 minus the cosine of delta x. So if you untangle the parentheses, you see I just rearranged this. So this is the sine of x plus delta x minus the sine of x. And if I divide by delta x, I get this. So this expression is the same as this. So this is the limit as delta x goes to 0 of sine delta x over delta x cosine delta x minus the limit as delta x goes to 0 of sine of x 1 minus cosine delta x over delta x. And when you take the limits, oops. This is sine delta x cosine x over delta x. This limit is 1, and this limit is 0. So this is 0, this is 1. We just get cosine x. So this is the proof. It's done more leisurely in the lecture, but it's always good to see this multiple times. And the proof that the derivative of the cosine is minus the sine is similar. And the last major differentiation formula in this section is for the exponential function. F of x equals e to the x, where e, which numerically is 2.718 something, has many definitions. One definition is that this is the limit of 1 plus delta x to the 1 over delta x as delta x goes to 0. Now you remember the exponential function has the property that e to the a plus b is e to the a times e to the b. That's the basic property of an exponential function. So if you want to calculate the derivative of e to the x, that's going to be the limit as delta x goes to 0, e to the x plus delta x minus e to the x over delta x. Let's just look at this. E to the x plus delta x is e to the x, e to the delta x. If I subtract e to the x, I get this. And then I can factor out an e to the x. This is e to the x times e to the delta x minus 1. So if I divide by delta x, that's what I have here. I have this. Now, if e is the limit as delta x goes to 0 of 1 plus delta x to the 1 over delta x, this says that when delta x is small, e is approximately 1 plus delta x to the 1 over x. So e to the delta x, if I raise this to the delta x, I just get 1 plus delta x. And if we use this approximation, this is approximately e to the x, e to the delta x minus 1 is delta x over delta x, which is e to the x. So this is e to the x. So this is actually a very sophisticated argument. It takes a lot of study to understand this, but in Math 175, it's an introduction to calculus, and you have to know the results and generally not the proofs. So the important fact is the following differentiation rule. The exponential function has this beautiful property that the derivative of e to the x is e to the x. So we now have a whole series of differentiation formulas, and as you go through the homework problems, you will use them more and more and more and become more and more familiar with them. Let me just spend a couple of minutes going over some homework problems. Does anyone have a particular problem they would like me to do? So this is an instance where the more you do, the better. So this is section 3.2. Problem number 5, y equals x to the 7th. We use the power rule. So the derivative of x to the 7 is 7x to the 7 minus 1, or 7x to the 6th. If y is equal to 1 over x to the 5th, you have to know exponents. 1 over x to the 5th is x to the minus 5. So again, by the power rule, the derivative of 1 over x to the 5th is the derivative of x to the minus 5. That's minus 5x to the minus 5 minus 1. That's minus 5x to the minus 6. That's minus 5 over x to the 6th. So the derivative of 1 over x to the 5 is minus 5 over x to the 6. Let's do a few that are not necessarily in the homework. If y, let's say number 17, s of t, this is a certain polynomial, t cubed plus 5t squared minus 3t plus 8. So the derivative, you do it term by term, is the derivative of t cubed plus the derivative of 5t squared minus the derivative of 3t plus the derivative of 8. So that's the derivative of t cubed. You take the 5 outside, plus 5 times the derivative of t squared, minus 3 times the derivative of t. Derivative of a constant is 0. Derivative of t cubed is 3t squared. The derivative of t squared is 2t times 5 is 10t minus 3 times the derivative of t, which is 1. So that's the answer. Number 21, y is pi over 2 sine theta minus cosine theta. So dy d theta, right? Theta here is the variable. It's pi over 2 times the derivative of the sine, which is the cosine, minus the derivative of the cosine, which is minus the sine, and minus times minus is plus, plus sine theta. Let's do one more. If y is a half e to the x minus 3 sine of x, dy dx, it's 1/2 the derivative of e to the x, which is e to the x, minus 3 times the derivative of the sine, which is the cosine. So these are some of the problems. Okay. There's one other part in section 3.2 that it's important to talk about. So it has to do with meaning or uses of the derivative. So the first was the slope of a tangent line to the curve, y equals f of x. The second has to do with rate of change. So you can think of some quantity changing as a function of time. And so let me use the variable t instead of x. And suppose, for example, s of t is the position of some particle. Could be a car, a rocket ship, an atom, position of particle at time t. And we want to know how fast it's moving. So this is a position function. And suppose there's some period of time from t to t plus delta t. So time t, let's say maybe t is whatever, 100 seconds. And then you want to know if delta t is 5. So s of t would be the particle's position at time t. And if like t plus 5 would be the position of the particle 5 seconds later. So how much did the particle move? It ended up at s of t plus delta t. And it started at s of t. So this is the difference between its ending position and the starting position. And the amount of time it took to make that motion, that movement, is delta t. So this ratio is called the average velocity over this interval of time. Right? Sometimes you write this as delta s over delta t, where delta s is the change in position, s of t plus delta t minus s of t. But when you're driving your car and you look at the speedometer, it doesn't tell you your average velocity. It tells you your instantaneous velocity, how fast you're moving in a given instant. And one way to define the instantaneous velocity, or what is simply called the velocity, is the following. I mean, suppose here is time and here is position, and here's the graph of your function. This is the position at time t. And at some particular instance of time, you want to know the instantaneous velocity. So you could say, okay, if you go from t to t plus delta t, s of t plus delta t minus s of t is how much the particle moves in this period of time delta t. So this average velocity over delta t time interval is this. And you just take the limit as delta t goes to 0. Of course, this is just the derivative, s prime of t, but that's what we call the velocity, v of t. So a second very important meaning or use of the derivative is to calculate velocity. Right? And the most important formula is if s of t is the height above the ground, if you start at some height and you drop, I don't know, a ball, and it falls to the ground, this is from elementary physics, if you like, the height of the ball at time t is given by 1/2 gt squared, it's quadratic, plus the initial velocity, like you could throw it down, give it some initial velocity v0, and s0 is the initial height. So this is a formula that you will use over and over again in this course, that the height of a falling ball, falling just under the influence of gravity, if you release it at height s0 with an initial velocity v0, its height at time t is given by this, and g is the acceleration due to gravity, which depending on your units is minus 32 feet per second squared, or minus 9.8 meters per second squared. Sometimes we use feet and sometimes we use meters to measure length. So this is a formula you really need to memorize. You need to have this in your head. And here's an example of the use. So again, the height at time t of a particle falling under gravity is 1/2 gt squared plus v0 t plus s0. Where in units of feet, g is minus 32 feet per second squared. So g over 2 is minus 16t squared plus v0 t plus s0. So in the example in the book, section 3.2, there's a diving board 32 feet above the ground, and a diver jumps off of the board with some initial velocity. And let's say so S0, the initial height, is equal to 32. And we're told that in this case, his initial velocity is 16. So this is 32 feet. The initial velocity is 16 feet per second. So this is minus 16t squared plus 16t plus 32. V0 is 16, S0 is 32. This is S of t. When does the diver hit the water? Well, when the diver hits the water, his height is 0. So for what value of t is minus 16t squared plus 16t plus 32 equal to 0? So this is just a quadratic equation we have to solve. If I factor out a minus 16, I get t squared minus t minus 2 has to be 0. Fortunately, I see this factors. This is minus 16, t minus 2, t plus 1. So this equals 0 when t equals minus 2 or t equals plus 2 or t equals minus 1. You don't go backwards in time. The answer has to be positive. So diver hits the water in t equal 2 seconds. And what is his velocity when he hits the water? Well, if S of t is minus 16t squared plus 16t plus 32, the velocity, which is the derivative of t squared is 2t. So this is minus 32t. Derivative of t is 1 plus 16 plus 0. So this is the velocity at time t. So when t is equal to 2, the velocity is 32 minus 32 times 2 plus 16. That's minus 64 plus 16. That's minus 48 feet per second. Okay. All right, well, this is section 3.2. And are there any questions about this or anything previous to this? If not, then I guess we are done for the morning. There will be an office hour tomorrow morning and Friday afternoon, and I'll post the hours for those later. Okay, that's it, everyone. Bye. No questions? No questions?